on Tuesday, after the homework is checked and reviewed, we're going to take a quiz on these position time graph calculations that we started working on yesterday. We're going to finish up today. The written assignment that you should complete in your packet for Tuesday is all of page 16. So you can make a note of that. That means all we have to do today is page 15. And then anytime we have left, I'll give you time to work on any lab corrections that you need to do. If you have a paper lab that needs to be corrected and you want to do it, you can do it with me now. I do plan to hand back your Unit 2 tests before you leave today. Those corrections are going to be due back by Monday the 27th. I'm pushing it back a little bit more than I might normally, because normally I say 1 week, Friday to Friday, but because I won't be here hopefully next Friday, if everything gives me good results, then I'm going to just give it back to me when I'm back on Monday. Okay, by the 27th, but you can just stick it right in this blue turn-in bin, and then I'll update your grade after I've checked those test corrections on Monday. Just make sure, some of you who did the test corrections last time did not get the signature that you need in order for me to even look at your corrections. So please make sure you do that. Maybe when you get it back, if you have a correction sheet, highlight that or something, circle it, whatever, to make sure you get that signature. Because without that, I'm not going to give you the credit. All right, any questions? Should be a pretty easy assignment. Okay. All right, and then if you don't have lab corrections to do, either virtual or paper, then you'll have time to start working on that homework. All right, so we are on page 15. So if everyone could please turn to page 15 where we left off yesterday. And what I've done now is I've given you another position time graph. We have a different position time graph being given to you. And what I'm going to have us do a little bit more than what we did, what they're asking you to do is I'm going to have you also write a description of motion for this. So either write the description of motion off to the side or maybe below it or above it. Can you go ahead and do that right now? Yep. You just share, but no Chromebooks out. So go ahead, take a minute and see if you can write a description of motion for this graph. Similar to how we started yesterday, we looked at a graph that was doing something and I asked you to write the description of motion. See if you can do that on your own. Anywhere, somewhere around that graph, go ahead and write a description of motion. All right, ready? Okay, let's check it. You should have told me that it was moving to the right and speeding up. That's your description. Moving to the right and speeding up. And if you wanted to, you could have also told me that the velocity was positive and the acceleration was positive. You should have also recognized that. Any questions on why it's doing any of those things or why the velocity is positive and the acceleration is positive? All right, I want to make sure you're clear on these are the kinds of things that you're going to be asked to do. All right, then let's go to part A. Part A is now asking you to find the average velocity of this car between 0 and 1.5 seconds. What kind of line do we have to draw on this graph? Janicia? Very good. This requires a secant line, which means we're going to start off by finding those two time points on this graph, which are here and here. And then with your ruler, what are you going to do? What does it mean, draw secant? Miriam? Yeah, you just connect them. So go ahead and do that with your ruler. I'm going to label this. This is my secant line, which I need for part A. And then we use our gas method, just like we did yesterday. All right. So I need to find 2 points that are on the line. I'm going to choose to use the 2 points that I was given because they are where vertical and horizontal grid lines intersect. So it's easy for me to read the coordinates and the precision of those coordinates. So this would be point 1. That would be point 2. So you're going to start off by telling me what the coordinates of point 1 and point 2 are. Anybody want to tell me the coordinates of point 1 with the correct precision and units? Chaudhry.
0.00 meters, comma, 0.0 seconds.
Reverse them. It's always the X, comma, the Y.
Always are.
Okay, so 0 point.
0.0 seconds, comma, 0 meters.
Correct. Yep. But you got the correct precision. That's all good. All right. How about point 2? Juan, you want to tell me?
1.5 seconds. 8.0.
Okay. Does this have the 0.0 on it? Okay. So just 8 meters. There you go. That's going to be necessary because of the sig figs that we want to give at the end. All right. Now, what am I going to write for the unknown? Devin, can you tell me what I'm going to write for the unknown? I'm not going to spell it out in words. Can you tell me what? That's right. V bar. That's called V bar. And then add the arrow to it. All right. Next step is the equation. Nikolai, can you tell me the equation you would write?
Y2 minus y1 over x2 minus x1.
Yep. Equals what? Yeah, you have to have both sides. If we don't say what y2 minus y1 over x2 minus x1 equals, it's not an equation and I have to take off. That's New York State rules. Okay, so we have to go with that. Kiara, you have a question?
Yeah, what's the bar again?
The bar means average. Okay, let's now go to our substitution with units. So V bar with the arrow is 8 meters minus 0 meters all over 1.5 seconds minus 0.0 seconds. Remember, we talked about yesterday doing the intermediate subtraction. So that would give me positive 8 meters. Now I see the sign that I'm going to need for the velocity and over 1.5 seconds. So now you're going to go ahead and divide that out. And we need to round our answer to proper units, sig figs, and direction. So I'll give you all a minute to do that. Alex, do you have an answer for me?
5.3 meters per second.
8 divided by 1.5. Your oh, yes, sorry. Now, sig figs.
We'll just need 5.
Yeah. So, and what sign are you going to put on it?
Positive.
Yeah, that's right. So positive 5 meters per second should be your final answer to this. Or if you wanted to, you could just say 5 meters per second, comma, right. You can give it to me either way. I think it's easier in this case to put the positive because that's what we have. Yep.
I have a question.
Yep.
Is it fine if you just put the 5?
No, it is not. That does not have sig figs. The fraction is a division. You have to divide it. Okay, this is not math class where they let you leave it. Math is just dealing with arbitrary numbers, not experimental data. Okay. If I ever looked up a scientific journal and they had a measurement given as a fraction, everybody would be looking at that scientist like, what the hell are you doing? Go back to college. All right. You got to divide it out. It's a division problem. Just give one numerical answer with proper significant figures. All right. Let's go to part B. Now I want you to find the instantaneous velocity at 1.0 second. Jacob, can you tell me what type of line I'm going to need to draw for this?
Tangent.
That's correct. This is going to require a tangent line. So the first thing you need to do is find this time point on your graph. Can you do that? Where is that time point on the graph? And you should see it right here. Now, I'm going to freeze my screen. I want to see if you can try to draw your tangent line like we did yesterday. Remember how we have to kind of envision zooming in on the point, making two little marks on either side of the dot, and then connecting them. See if you can do that yourself. I'm going to do it on mine as I freeze the screen, but I want you to try to do it yourself and then get your tangent line drawn. And you're doing it in pencil, so if you make a mistake, we can fix it. Okay, y'all have something drawn? All right, let's check it out. Here is my tangent line that I drew. The most common mistake that I see with these tangent lines is kids just want to connect 0 to the data point at that time. That's not right. The tangent line, you should be trying to zoom in on that point right there, which you can see. I just did that here. I put my two little marks. I connected them. And what I did to make this a little less confusing than what I did yesterday is I did it in a separate color. So that way, when I'm looking for my points, I can see it. But you're just going to do it in your regular pencil. I'm just doing that so that way right now you can see which one is my tangent versus which is the secant, especially because they overlap in this area down here. Does yours look something like that? Right. Remember, we're all going to get something slightly a little bit different. The only way you would get the exact same thing that I have is if you photocopied my paper, which none of you has a photocopier in the room, so you're not going to be doing that. Chaudhry, you have a question?
For tangent, you said to like zoom in and try to see if you can see a line.
So you're zooming in. You have to imagine zooming in, and you make your two little marks on either side of the dot. Okay, and then you just connect those and expand it as far as you can. Okay, now if you haven't, please go ahead and label that. That is your tangent line that you're going to use in part B. Okay, you're going to use, this is your tangent line that you're going to use in part B. So now what we have to do is find 2 points, and I'm on that line that you just drew, and circle them. Try to find 2 points where the grid lines intersect. That way you can read the coordinates easily. So like I'm going to pick this point right here. You see why I'm going to pick that one? It's on a vertical line and it's right on the x-axis. So that's an easy point for me to choose. That's going to be my point 1. And then I'm going to look from here coming this way. That way they're as far apart as possible. I don't know if I'm going to have another one. Actually, I do. I have it right at the 1 second time. Point 2. Okay. You don't have to use those 2 points. You can use whatever 2 you want as long as they are on your line. And then what I have to do when I grade it is check the coordinates you pick. Are they on your tangent line? And was your tangent line drawn appropriately? If it wasn't, then I can't give you credit for it. I think that makes sense, right? Okay, so let's now go ahead and list the givens for those 2 points. Ryan, did you have the same 2 points on yours?
Yeah.
Okay, can you tell me what the coordinates of point 1 are then, please?
0.5 seconds.
Yep,
0 meters.
very good. All right, so the coordinates of point 1 are 0.5 seconds and 0 meters. And Gianna, are you using the same second point that I am? What do you have for that?
No.
You're not. Okay.
Wait, is that the? Yeah, I am.
Okay, go ahead.
1.0 seconds and 4 meters.
Good. Vincent, can you tell me what I'm going to list as my unknown? Okay, look back at what we did yesterday. Turn the page back. What did we write for the unknown for the velocity calculation at one time point? That's it. So what the difference is that when I want an instantaneous velocity, there's no bar. The bar means average. So this is just the velocity at one time, like what we were doing in the last unit. All right. Sydney, can you give me the equation that I should write for this, please?
Velocity with the arrow equals over
That's right. So let's do our substitution with units. So that would be 4 meters minus 0 meters all over 1.0 seconds minus 0.5 seconds. Now the rule is we keep precision. So in the numerator, that would give me positive 4 meters. The denominator would give me 0.5 seconds. That keeps the precision out to the tenths place. Numerator has 1 sig fig. Denominator has 1 sig fig. So you're going to round your answer now to one significant figure. Nikolai?
We're not doing any checks on these type of questions.
Only if I told you to.
Okay.
And right now, that's not what I'm concerned about. Miriam, can you help me out with an answer for that, please? Correct. Yeah. And you don't have to give me both on a test or quiz. You would just give me one of those. But yes, those are both correct. Okay. Any questions? No, we're good? Okay. I want to point out something to all of you. We only have 2 more sections left in Unit 3. 2 more. And those are going to be tackled next week. Hopefully by video. All right. So that means we're going to start to get ready as well for your Unit 3 test. And I want to show you where the review materials are for the Unit 3 test because you can actually start working on some of this now. It may actually help you in preparing for the Unit 3C quiz and going back and reviewing Unit 3A and 3B. You know, if you start working on it, this gives you lots of time to work on it because I'm not going to review it till after I'm back. So for example, the review materials start on page 29. They start on page 29 in the packet. And basically it starts off with a study guide. Right now, you should be able to complete this chart here, the measurable quantities. Basically, what I'm asking you to do is if I give you these symbols, what do they stand for in words? If it's a scalar, if it's a vector, and then what units are they measured in? You should just know this kind of stuff. Okay, you can use your reference table to help you with the words if you need it, because they are on your reference table. Then you should be able to do all of these definitions, filling in those blanks. These are the definitions. You have to tell me what physics term is associated with those. If you don't know, that's a good way to start going back and reviewing because you should know that stuff. Don't worry about the equations yet because we haven't gotten through all that. That will come to you in the last section of Unit 3. But on the next page, page 30, you can do most of this chart. Basically, I'm asking you for the different patterns. You can do all of them. You can't do this one yet. Actually, I think you can because this is Unit 2. A lot of this you can do now. Okay, a lot of this you can do now. This one is going to get tackled on Monday. So you could start those off. And then on the next page, look, I'm even giving you more ways to kind of put everything together. These are the descriptions of motion. You should be able to tell me, is the velocity positive, negative, 0 based on the description? Is the acceleration positive, negative, or 0? You should be able to draw the ticker tape that represents that motion. You should be able to sketch in the position time graph in the first quadrant for that motion. And you should also be able to sketch in the velocity time graph for that motion. This kind of starts to put it all together for you. And this is all stuff you should already know. This is not new and it won't be covered next week. So starting to review these concepts now will help you in the longer term, right? Because prepping for a big football game, you're not going to just go to practice the night before the game. You got to practice all season. And that's what I'm trying to do is get you practicing in little pieces as you go. So those are things you can work on. And that's probably it for at least now. Okay. So those are things you can work on as well. So what I'd like you to do now is go back to page 16. If you want to start working on this homework now, you can. There's only 3 problems I need you to do tonight. This is the graph that you're going to be drawing your lines on. Well, I say tonight, this weekend. And then if you finish that, you can start working on the review at the end, those few pages. Start looking back in your notes. You can work with each other on it and so forth. All right. Any questions for me? All righty. So that's it for today.